If Neptune is further away from the Sun, then why is Uranus cooler than it? The two most distant planets in the solar system, Uranus and Neptune, are comparable in that they both belong to the icy giants category because of their low temperatures. Neptune is the planet with the greatest distance from Earth, but Uranus has the greatest cold. Why is this taking place? Let's investigate. We have seen that in the solar system, the planets nearest to the Sun are typically hotter while the planets farthest from the Sun are typically colder. Since Venus is the hottest planet despite Mercury being the closest, this rule is not always adhered to. Since Uranus is colder than Neptune despite being a billion kilometers further away, a similar phenomenon occurs there. While Uranus is the second farthest planet in our solar system and is colder at a distance of only 2,880 million kilometers from the Sun, Neptune is the planet with the greatest distance from the Sun at 4,500 million kilometers. Distance is less significant in the atmosphere, while the planet's distances from the Sun are an important factor in determining their temperatures. The atmosphere is likely even more important. For instance, Venus is much hotter than Mercury because Venus' dense atmosphere traps heat and does not let it out, creating a long-lasting greenhouse effect that keeps the planet's surface consistently above 480 degrees Celsius. Understanding why Uranus is cooler than Neptune depends in large part on its atmosphere as well. With a minimum temperature of 49 K or 224 degrees C, Uranus has the solar system's coldest atmosphere. It also features a very complicated cloud structure that is organized into levels, with the lowest clouds thought to be made of water and the highest of methane. Although Uranus lacks a clearly defined solid surface, the atmosphere refers to the region of its gaseous envelope that is the most visible from a distance. This atmosphere is different from the rest of the planets in that it primarily consists of molecular hydrogen and helium. Additionally, Uranus has a low thermal flux, which means that its internal heat appears to be lower than that of the other giant planets. Why Uranus has such a low interior temperature is still a mystery. One explanation for this mismatch is that Uranus received an impact that resulted in its high axial tilt and caused it to release the majority of its primordial heat, which decreased the temperature of its core. Another theory is that Uranus's upper layers include a barrier that keeps heat from the core from reaching the surface. For instance, convection in a collection of layers with various compositions can prevent heat from being transported upward, causing Uranus to lose heat more slowly than the other planets. When compared to the other gas giants at ultraviolet and visible wavelengths, especially when compared to its twin Neptune, Uranus' atmosphere is remarkably smooth. In 1986, Voyager 2 passed close to Uranus and counted 10 different types of clouds there. There aren't as many as Jupiter or Saturn, where there are significant temperature differences between the cloud layers and can result in hurricanes and eddies that can last for centuries. One theory as to why this is the case is that Uranus' low temperature prevents too many mixtures of gases with different temperatures from forming, as happens in those planets. There aren't many temperature changes on Uranus. In fact, the lowest temperature ever measured in the planet's tropopause was 49 K, making it the coldest planet in the solar system and the gas giant with the calmest atmosphere. A bright polar cap and dark equatorial bands were found to split the visible southern hemisphere of Uranus into two parts in 1986 by Voyager 2. But in the 1990s, there were a lot more bright cloud forms observed, in part because there were new, high-resolution image processing methods available. Because of their tilt, it was found that the majority mostly appeared in the northern hemisphere. Neptune, on the other hand, experiences extremely little heat due to its elongated orbit around the Sun. 218 degrees Celsius or 55 K is the temperature at its surface. The planet does, however, seem to have a heat source from within. It is believed that this heat may be a byproduct of the concretion of materials during its formation, which is now slowly radiating heat into space. Strong climatic systems are produced by this internal heat source all around the planet, including the Great Dark Spot, which the Voyager 2 probe found in 1989 while traveling through the Neptune system. According to a different theory, Neptune's interior has the perfect circumstances for the fusion of carbon atoms into crystals, which produces heat. As a result, this theory suggests that diamonds may rain from Neptune. The somewhat higher concentration of helium in Neptune's atmosphere accounts for its different color from Uranus. As a result, compared to its neighboring planet, Neptune absorbs more of the sun's red radiation, which causes it to reflect a considerably more intense blue. The band structure of Neptune's atmosphere resembles that of the other gas giants. On this planet, phenomena like enormous hurricanes with a diameter comparable to that of the Earth and various cloud forms, such as some expansive cirrus clouds above 50 kilometers, the main clouds, are common. Thus, Neptune has a cloud system that is extremely active, possibly even more active than Jupiter's. Additionally, Neptune has the highest solar system-wide wind speed of up to 2,000 kilometers per hour, which is thought to be fueled by internal heat flow. At high altitudes, Neptune's atmosphere is composed of 80% hydrogen and 19% helium. Additionally, there is a small amount of methane, which results in distinct methane absorption bands in the red and infrared spectrum at wavelengths above 600 nanometers. Storm systems that are exceedingly dynamic and produce winds of over 600 meters per second or 2,200 kilometers per hour and nearly supersonic flow rates are typical of Neptune's meteorology. More frequently, wind speeds have been seen to fluctuate from 20 meters per second in an easterly direction to 325 meters per second in a westerly direction, a huge differential that results in hurricanes that are more powerful than those of Jupiter. The average wind speed at the top of the clouds varies from 400 meters per second near the equator to 250 meters per second towards the poles. But generally speaking, most Neptune winds move in the opposite direction of the planet's rotation, similar to what occurs on Venus. As a result of its interior heat source, which produces more storms, winds, and a continuous exchange of temperatures between inside and external clouds, Neptune is a far more active planet than Uranus. As opposed to the other gaseous planets, Uranus has a considerably calmer atmosphere with fewer temperature exchanges, which means it experiences fewer storm clouds and hurricanes. Both planets' inclinations. If there is one thing Uranus is known for, it is that it is the only planet in the solar system to be almost entirely inclined to the sun at an angle of 97 degrees. This results in changes in the seasons in a completely different way than the other main planets. While Uranus rotates like a ball rolling inclined, the other planets can be thought of as spinning tops inclined with respect to the solar system plane. One pole of Uranus always faces the sun as its solstices approach, while the other always faces in the other direction. Only a small area near the equator experiences a quick cycle of day and night, with the sun rising very low over the horizon, as it does in the polar regions of the planet. The poles are oriented in the direction of the sun on the opposite side of Uranus' orbit. In a world where you would have to wait 42 years to see the sun again, each pole receives around 42 years of unbroken sunlight followed by 42 years of darkness. The planet's tilt prevents the night side from ever seeing a single ray of sunlight for a very long time, which significantly lowers the temperature of the planet. Neptune, on the other hand, has a much smaller inclination angle of only 28 degrees, which provides it much excellent stability in its annual seasons because, like the Earth, the only places where it experiences less heat are at the poles. However, the sun always shines on the rest of the planet. In conclusion, we may say that the three factors that account for Uranus' cooler temperature than Neptune are its atmosphere, tilt, and core. 1. As we can see, the atmospheres of the two planets are considerably different, with Neptune's being far more active and Uranus being remarkably peaceful and devoid of storm clouds. 2. Due to Uranus' 97 degrees tilt, which allows one of its hemispheres to stare directly at the Sun for 42 continuous years while the other remains in complete darkness for the same amount of time, the planet experiences extreme weather on its surface, which leads it to become even colder. Neptune, on the other hand, has a fairly regular inclination, which prevents it from experiencing the same jarring temperature variations as Uranus does. 3. And finally, arguably the most important factor in why Neptune is warmer than Uranus is that it has an internal heat source, whereas Uranus does not. The reasons why Uranus lost this heat source are still up for discussion, but the currently accepted theory is that billions of years ago, a massive body collided with Uranus, causing the planet's tilt axis to remain as it is today and also causing the heat of its core to dissipate more quickly, cooling the planet. If Uranus had a heated core like Neptune's, it most likely would have a greater temperature as well, making Neptune the coldest planet rather than Uranus. For the time being, we are unsure, but possibly in the future, with fresh studies and spacecraft that visit this planet, we will be able to unravel all the mysteries surrounding these two planets that share more than meets the eye. The majority of exoplanets in the galaxy are expected to be rather similar to Uranus today. Do you believe we ought to try harder to learn more about this planet? Comment below with your thoughts and let us know.